This video is over section 9.4 over properties of logarithms. So the first property that we want to talk about is the product property of logarithms. It says let b, x, and y be positive real numbers where b is not equal to 1. Then log base b of xy equals log base b of x plus log base b of y. So what that says is the logarithm of a product, so right here we have a product, equals the sum of the logarithms of the product. So we break out x and y, and it becomes, I'll use green there, a sum. Okay, so for these, it says write the logarithm as a sum and simplify if possible. Assume that a, c, and d represent positive real numbers. So I have log base 4 of 16a, and what that says is 16 times a, so we can break that up with addition. So this is equal to log base 4 of 16 plus log base 4 of a. This says simplify if possible, so over to the side, if I have log base 4 of 16, I'm going to use pink. What that means is 4 to the something equals 16. And if I get 16 with the base 4, that would be 4 squared. And now that I have base 4s on both sides, that means that x is equal to 2. So I used pink to show you this scratch work off to the side in pink. And I can replace log base 4 of 16 with a 2. And then I'm going to bring down my plus log base 4 of a. So I separated them into a sum, and then it says simplify if possible, and I used pink to simplify. So I guess I could use black here, but we can box the answer there. Okay, so breaking out into a sum, and the simplified answer would be 2 plus log base 4 of a. All right, let's look at the next one. We have log 12 CD. And remember, if we're not given a base here, that's a base 10. Okay, so if I break this out into a sum, that's going to be log 12 plus log, sorry, I should not be using pink. Let me switch this to blue so you're not getting confused. Okay, sorry, log 12 CD is equal to log 12 plus log C plus log D. And on the left one, we were able to simplify with a base 4. But if I look here, I'll use green. If I look here and I know the base is 10, 10 to the something equals 12. There's not a whole number for that to give me 12, so we're not going to simplify that. Okay, so that's the best answer. Again, I'll use black just to be consistent. There is no simplifying. All we could do is break it out into addition by the product property of logarithms. All right, next would be quotient property of logarithms, and it says let b, x, and y be positive real numbers where b is not equal to 1. Then log base b of x over y is equal to log base b of x minus log base b of y. The logarithm of a quotient equals the difference of the logarithms of the numerator and logarithm of the denominator. So similar to what we did up here, let me bring out the highlighter to show. But here we have a quotient or division. And when I have division, I can break it into two logarithms by subtracting the numerator, the logarithm of the numerator minus logarithm of the denominator. All right, so for these next two, very similar. It says write the logarithm as a difference and simplify if possible. Assume that t represents a positive real number. Okay, so what this says, if this is division or a quotient, so we can separate by the quotient property. We're going to have log base 6 of 8 minus log base 6 of t. It says simplify if possible, but if I look at this, 6 to the something gives me 8. There's not a whole number that could give me 8, or even like an easy fraction, so we're just going to leave that for now. I don't think on your homework it'll make you simplify. If it does, I'll come back and either upload a second video or offer a correction, but I think it will let you leave it as log base 6 of 8 if, yeah, I think it will. If not, I'll come back and make a second video for that. All right, assume that t represents a positive real number. So for this one, sorry, I don't know why I said that. We did that here, so t is a positive real number. Okay, second we have ln e over 12, and since we have a quotient, we can use the quotient property. So what that gives us is ln e minus ln 12. It says simplify if possible. If I look at this ln of e off to the side in pink, that means e to the something gives me e. And I remember I get that first e from this invisible base e on the ln. And the only way for e to the something to give me e is if that something is 1. So in pink, I'm going to come back over here and place that with a 1. I can't simplify ln of 12 because if I use a different color here, e to the something equals 12. There's no whole number that will give me 12. So we're just going to keep it as simple as we can. Instead of having a crazy decimal, we're going to just keep it minus ln of 12. So that right there is the best answer. Let me box this too. Okay, the next property is the power property of logarithms. It says let b and x be positive real numbers where b is not equal to 1. Let p be any real number. Then log base b of x to the p is equal to p log base b of x. So really quick, all they did is they took their exponent and brought it into the front. Okay, so if we're looking at this next section, it says apply the power of logarithms. So if I have log base 5 of x to the fifth root of x to the fourth, that's a lot. What this is really saying is log base 5 of x to the 4/5. So that's a review, but this fifth root is really 1/5. I guess I can break it down for you off to the side as a review. If I have the fifth root of x to the fourth, this is like x to the fourth to the 1/5, which would be x to the 4/5 if you multiply here. Okay, and then by the power rule says that we can take our exponent and move it into the front. So by applying the power rule, this would be 4/5 log base 5 of x. Okay, for this next one, we have ln x to the fourth, and our exponent is 4, so we can move that 4 into the front. So the best way to write this would be 4 ln x, and that one's just really simple. There's nothing much to do. That base is e. There's no way to simplify further. All right, so now we're going to look at all the properties together. It says let b, x, and y be positive real numbers where b is not equal to 1, and let p be a real number. Then the following properties of logarithms are true. Number 1, log base b of 1 is 0. Log base b of b is 1. Log base b of b to the p is equal to p. B to the log base b of x equals x. And then the product, quotient, and power property, these are all from this current video. 1 through 4 was a review from the last one. Okay, this next section says write the expression as a sum or difference of logarithms. So we're trying to break these out as far as we can. Notice on the top of the logarithm, that's multiplication, and then we're dividing by the bottom. So first, let's break out all of that. So we're going to have ln of a to the fourth plus, because there's multiplication, ln of b minus, because we're dividing, by ln of c to the ninth. So that is, let's just keep our notes clean. This is the product and quotient rule. Okay, and then notice here we have exponents or powers, so we can move those in front further. I wish I'd use a different color, but if we move those in front, the best answer for this problem would be 4 ln of A plus ln of B minus 9 ln of C. And there we used the power rule, or the power property. Great. All right, log base 5 of the cube root of 25 over a squared plus b squared. So there's a lot going on here. Wow. Okay, I'm going to try to write small. So the first thing I want to do is take all of this to the third root and then kind of bring that out in front. So the power rule, so log base 5 of all of this to the 1/3. That just makes our life a little bit easier. And then I am going to move that 1/3 to the very front by the power rule. So I guess let me label that. So power rule. When I do that, I'm going to have 1/3 log base 5 of 2 over a squared plus b squared. Next, I'm going to use the quotient rule because I have that division there. So I have to keep this 1/3 out in front. And then I'm going to have log base 5 of 2 minus, because of the quotient rule, log base 5 of a squared plus b squared. Okay, so I guess let me label this quotient. I'll make this division sign in orange and say quotient. So you know that's what we're doing next. I'm going to apply the power rule again by taking this 2 into the front of this log. So I'm going to have 1/3 of log base 5 of 2 minus 2 log base 5 of a squared plus b. And I'm going to leave it at that because we don't have a property that deals with addition inside a logarithm. So that's probably the best answer. I think the textbook would take this. They might make you redistribute that 1/3 in there. That should be good. Let me write power rule here so you remember what we were doing. All right, the last section says write the expression as a single logarithm and it simplify the results if possible. So we're combining this time. So here we have addition, so that would be the product rule. And here we have subtraction, so that would be the quotient rule. Okay, so when I do that, and they're all log base 3, so base 3 is important, but log base 3, and then we're going to have on top, we're going to have 54 times 10 over 20. So that's going to be log base 3. I'm going to use my calculator to be safe on the math there. Log base 3 of 27. And what this is asking us is, I'm going to put equal sign here. I'm going to use pink, but what this is asking us is 3 to the what gives me 27, and 3 to the what would be 3 cubed. So this is equal to 3. So as one logarithm, that would be log base 3 of 27, and then simplifying would be just 3. Okay, here we can apply the power rule, and then we have a subtraction, which would be quotient, and another subtraction, so that would also be quotient. Okay, so, and they're all common log, so they're all base 10. So here we're going to have log of x cubed divided by, oh, I guess here there's a power and power there too. Hopefully you can see that. So if I do that, I'm on the bottom, I'm going to have y to the 1/3, z to the 2/3. It is a little, you could probably stop here. I don't think your homework would make you keep going. It is a little suspicious to have those 1/3 on the bottom, so we could take out to get a cube root out. And so to get that, we would have x to the 9th y z squared. I don't think that these are the same. I don't think it's going to make you keep going from what I boxed, but it might. All right, last one, natural logs. Here we're going to have a power rule. Here we have a product rule. So let me write power up here. Here we have a quotient rule. Okay, so we're going to have the natural log of t to the 1/3 over, oops, that's not over, times t squared minus 9 over t minus 3. It does say simplify if possible, so I think it's going to make you keep going. And in the numerator, we keep that t to the 1/3, but we can break out t minus 3, t plus 3 if we factor. Okay, and when we do that, these t minus 3's cancel. So we're left with t to the 1/3, oops, t to the 1/3 times t plus 3. It does want, like, sorry, that's kind of weird notation. All of that is in the same natural log. It does want one logarithm, so I guess that is okay. There's probably a way you can simplify kind of like we did here, but I think the book would, or like the online homework will take that as the answer. So I'm going to go ahead and box it because it is a single logarithm. We do need to note that t cannot be 3 because that would give us a 0 in the denominator.